Since I have a grasshopper mind and am always being diverted by other interests, I could see that this 9F idea was going to be a long-term project. Quite how long I didn't bargain for, though perhaps my model of Brunel's Great Western, started in 1968, and though it's been sailed under radio control, still requires a proper set of rigging, should have been an indication. Therefore, as far as track was concerned, what I needed was a system that was not going to rot or rust. I was put in touch with Nev Bolton, who constructed a 1,000-foot 5-inch track in his garden. It was known as the Great Bulkington Railway. I emailed him and he invited me to visit. His track design used recycled plastic for sleepers and stainless steel fixings. It was just what I was looking for. Nev was a great help. He gave me details of his suppliers and showed me a jig that he had designed to ensure that the pilot holes in the sleepers could be drilled accurately and rapidly. My garden is on a slope, and it was difficult to find a flat area. Eventually I came up with a plan for a modest 24-metre test track that would run from our tree house to a fence at the other end. The only problem was that the shed had to be moved. My wife and I managed to lever it back on greased wooden beams, but the shed door would still open over the track. I came up with a novel solution. From inside the shed I screwed all the parts of a door and door frame to the end wall of the shed. Then I sawed down some of the hinge side planks and from outside fitted hinges. Finally I put in extra screws from the outside, sawed all around the door, and voila, there was a new entrance. Using Nev's information, I ordered the sleeper material. 16 lengths of 50mm by 50mm black recycled plastic from BPI Recycled Products, and they agreed to supply it slit down the middle, which would save a lot of work. I set up my miter saw with a stop and rapidly turned out about 200 10-inch sleeper blanks. This image shows the jig I made to carry out the pilot hole drilling. It was built of wood, but to prevent wear I made hardened steel inserts for the drill holes. Each sleeper had 6 screws, except for the ones at the end of each section, which had 8 screws. To avoid errors, I covered the holes of the version I was not drilling with tape. To use the jig, one simply had to drop in the sleeper, pack one side with a piece of cardboard to take up the plastic tolerance, put the lid on, and drill the holes using a stop on my pillar drill. I soon became pretty swift at the operation. I decided to mount the track on a double layer of scaffolding planks, supported just above ground level on concrete block pillars. I staggered the joints, and between the layers I gave the contact surfaces a liberal coating of engine oil, before screwing them together with stainless steel screws in one long continuous unit. I then widened the surface slightly with 3/4 inch wide wooden strips nailed on with stainless steel nails. This brought the width up to 10 inches. To protect the top, I bought a large 30-metre roll of 300mm wide black plastic damp-proof material to fit between the planks and the sleepers. Sorry about all this mixture of units, but that's how they came. Owing to tolerances in the slitting, the thickness of the sleepers varied somewhat. This would not be a problem when supported on ballast, but since my sleepers were going to sit on a rigid surface, I needed to avoid steps. I was not keen to have to machine them all to a uniform thickness, so I measured every one and stacked them on a shelf in sets of gradually increasing size. That worked out fine, and I still have enough for one more rail section. I bought 14 4-metre lengths of 5/8 inch aluminium rails, plus fish plates and fixings from the Miniature Railway Supply Company Limited. Then, from a local company, I bought 1,000 A4 stainless steel posi-drive screws and 1,000 A4 stainless steel M5 washers. I was practically ready to go into production. However, to hold the rails at the correct gauge, I made a couple of jigs that I could slide along as I worked. Using 2 garden tables on my patio and an electric screwdriver, it was simply a matter of putting in nearly 1,000 stainless steel screws and washers. This took less time than you might imagine. To space the sleepers, I used an 11cm wide spacer that had a lip to keep it square, but I reduced this spacing near the joints. There was only room for 6 lengths of track, providing an overall length of 24 metres, but that was okay for a test track. I screwed every 4th sleeper to the planks with 2 A4 stainless steel screws, and then tacked down the edges of the damp-proof material with stainless steel nails. The last thing was to keep the planks in place, which I did by hammering in lengths of galvanized steel pipe from a skip at intervals either side. Now in 2022, it doesn't look much different to when it was first laid in about 2003. Following these videos, you might think that everything progressed in a steady, continuous sequence. That was not what happened. Many other projects intervened, sometimes for years. To illustrate this, here are a few of them. I started this 5-foot model of Brunel's Great Western in 1968 based on a set of plans that the Science Museum had used to build their model. It's shown here at speed in front of the Bristol Council House. The work progressed in fits and starts, and the model still needs proper rigging. However, it has crossed the lakes at Portishead and the University of Bath under radio control. This schooner was bought on eBay as a hull in poor condition. I completely rebuilt it, and it has sailed on the Marine Lake in Clevedon. Casting the detachable lead keel was a bit exciting. I finished it off on my lathe. Never again. Piles of lead everywhere. Rhoda Z was given to me by a local family. They had inherited it from their father, who'd built and sailed it in the 1950s. Since then, they'd moved house several times, and it had lived wrapped up in a garage and then in an attic. It was offered to me if I would look after it. It arrived looking like a mummy. As I unwrapped it, the illusion increased, since the paint had become sticky and it was embalmed. I didn't know what to expect, but it turned out to have a boiler and a twin-cylinder steam engine with a marvellously complicated control system. I've overhauled it and repainted the hull inside and out. In 2013, I began to realize that by the time I finished my 9F, my grandchildren would be grown up. I decided to build a quick, simple loco to run on the track, and after looking at lots of possibilities on the internet, based it very loosely on a Triang Dock Authority diesel shunter. On eBay, I stumbled across a Cebici 2-slice toaster. One end of it was a dead ringer for the front of the shunter. It was listed as new but faulty, and nobody else put a bid on it. Hence the toaster train was born. It was just the right size to accommodate one of the 12-volt 33 ampere-hour batteries that I had bought for the 9F. The top grills are serve-form blades, and the front grill was cut from another part of the toaster. The aluminium was eBay offcuts. There's a working front light and a horn. It has no problem pulling a truck with an adult and several children. I emailed a photo to the toaster seller, and they were delighted that it had been put to good use. There were plenty more projects: mechanical, electrical, electronic and microcontroller. But I think I've illustrated why the electric 9F has taken 20 years. Part 5 goes back to the 9F and has a lot of content, so I'll split it up. Part 5A, the motor characteristics and the control strategy. Part 5B, how the control strategy was implemented. And Part 5C, the rather unconventional sound system.